All right, so let's move on from probability density functions, PDF, to a cumulative distribution function, or a CDF. Now, CDFs are pretty much what you're going to use uh, 99% of the time compared to PDFs. I can't think of a scenario in the rest of this class where you're going to use a PDF. So let's talk about what a CDF function does. And I'll talk about both the Texas Instruments and the NumWorks here. Um, so what a CDF function does is we can put in a value of x, and what it'll do is it'll give us the area under the normal curve adjacent to that value of x. So if we put in this normal distribution curve, if we put a value of x of 190, it will give us the area adjacent to it. And because the center of the distribution curve is the mean, and the mean was 190, then we would expect the area to be 50% or half, because the total area under the curve is 1 or 100%. So remember, with the PDF function, if we put 190 in, we got 0.0399 out. That was the value on the y-axis. That was a part of this ordered pair. But now with a CDF, if we put 190 in, it's not going to give us the coordinate for this point. It's not going to give us the y value for this point. If we put 190 in for x, it's going to give us the area next to it. Area. Okay. And remember, area is probability. So let's do this really quick on the Texas Instruments calculator. And I'll go ahead and bring up the NumWorks calculator as well. Let me get myself out of here. Okay, and let me clear this out. There we go. And let me go here. Quit. There we go. Let's clear that. All right. So what we want to do is we want to calculate the area to the left of 190. So we want to get to the distribution functions. So second, vars. And now instead of PDF, we want CDF. Click enter. Now, you'll notice that for a CDF, it doesn't just ask for a value of x. It's asking for like a lower bound and an upper bound for the area. So let's look back at our notes here. And you'll see that if we wanted to describe this area, how would we describe it? Well, we would describe this area as having an upper bound of 190. And because the area goes on to infinity in a negative direction, we need to put a lower bound of negative infinity. So this area is defined by the upper bound of 190 and a lower bound of negative infinity. And so that's what we need to actually put into this calculator, into the Texas Instruments. So let me show you. So you might have something like this. So the lower bound for this area to the left, we need a way of putting in negative infinity. All right. There isn't a negative infinity button as far as I know. So the trick is to put like a really large negative number. And the easiest way to do that is to put like a negative 10 to the 99. That'd be, a 1 with 99 zeros behind it. Now, To do that on the Texas Instruments calculator is you want to hit the negative button. So the negative button is down here next to the period button. You don't want to use minus. If you do minus, you're going to get an error. Okay, so don't do that. Use the negative button. So we want to put a negative E99. So to get the E there, notice that we've got these two blue EEs above the comma button. So hit second, then the comma, it'll put a little E there, and then put 99. That effectively means in the negative infinity direction. Okay, now the upper bound for the area was 190, and our normal distribution had a mean of 190 and a standard deviation of 10. So now if I hit enter, so it pasted that function with all of the input arguments. If I hit enter again, that's my area. So it's 50%. Now, this is where I think the NumWorks calculator is better than the Texas Instruments, and that it gives you a more visual reference to do the same thing. So what you want to do is go to the home button and go down to the distributions app and click OK. And now we want to go to the normal distribution. This is where we put in our mean. So you see right now, it's a little more visual, right? It's prompting you for what you need. And I guess the Texas Instruments to do that. But let me show you where this is a little bit better. Now we're looking at a picture of our normal distribution. And right here, we can actually choose whether we want the area to the left, we want the area to the right, or we want the area in between two values of x. So we kind of don't have to worry about this negative infinity business. We can just say, well, we want the area to the left and choose that. And we want the area to the left of 190. So what's the probability that x will be less than or equal to 190? And if we hit execute, it tells us 0.5, and it shows us this picture, which shows 190 here in the middle, and the area to the left of it, which is equal to 0.5, or 50%. So I think for students that are learning distributions, seeing this visual picture and the values that you put in helps you kind of learn this concept, I think, that much better because you get to see this with your eyes, and that helps you kind of get that image into your brain. Whereas the Texas Instruments calculator, you don't have that right away. Okay, so that's how you can use the normal CDF function on the Texas Instruments to get an area. And this is how you can use the distribution app to get the area to the left or to the right. Now let me actually show you how to get the area on the other side. Okay, and let me go kind of in reverse order now. So let's say instead of the area to the left, I wanted the area to the right. On the NumWorks calculator, I would just need to come over here, click OK, say I want the area to the right, and change that to 190. And now it's giving me the area to the right of 190. See, values of x that are greater than or equal to 190, that would be up this way, and that is 50%. If I come over to the Texas Instruments, I need to go back to normal CDF. All right, but now what we need is if we look at the NumWorks calculator here, now our lower bound is 190 for this area, and the upper bound is positive infinity. So what we need to do is we need to change these values here to be a lower bound of 190 that has an upper bound that goes off to positive infinity. So we need to put E99, E99, like that. And then if we go down to paste and hit enter, so you can see that that's essentially 50%. I don't know why it's off a little bit there at the end, but it should be exactly 50%. So, what I like about the NumWorks calculator is it gives you the visual consequences of the values you put in. This kind of serves as a secondary check for what you're doing. Over here on the Texas Instruments, because it doesn't give you that visual feedback, you might have made a mistake, but you wouldn't see it on the distribution itself. Okay. Yeah. All right. So that is getting the area. Yeah, let's keep going with this because there's just more values just to kind of show you um, how we're doing this. Actually, I'll go ahead and stop here. If you feel comfortable with this, you can skip the next video. Um, yeah, let's stop here. I'll create another video where we kind of punch in some other values. Okay, so you can get a better idea of how all this works. All right, let me know if you have any questions.